Good morning. Today we're going to talk about constant of proportionality. So we're still going to be working with ratios, but now we're going to be working with more than one ratio at a time. So two quantities are considered to be proportional. So you guys can fill that in if you've printed this out. Proportional if the ratio between the quantities is equal. Okay, and we're going to talk about what that means to have an equal ratio. So, here's an example we're going to look at first. Mario travels 180 miles in 2.5 hours. If he travels at the same rate, how far can he travel in 5 hours? Okay, so the first thing we're going to do here is find how can we take and solve this problem. There's two different ways to take and solve this one problem. First, I'm going to show you using unit rate because that's what we've been working on, and then I'm going to show you using actual proportions and using the steps for doing that. So, 180 miles in 2.5 hours. Okay, we're wanting to find out how far can Mario go in 5 hours, but we're going to start because we're trying to find the unit rate, so we're going to do it in 1 hour. Okay, and then all we're going to do, just the same thing we've been doing, we're going to take and divide that 180 by 2.5, and then we're going to get 72. So he's traveling 72 miles per hour. Okay, to find out how far he travels in 5 hours, we would just take that 72 and multiply it times 5. Okay, so 72 times 5 gives us 360. Okay, this is one way we can take and solve this problem. Now, I'm going to show you an easier way where we're setting up proportions. And there's two ways to solve these proportions depending on what they look like. So I'm going to erase this work. So now there's three different ways that I'm going to be teaching you to do this, okay? So start with our initial ratio again, 180 over 2.5. And we're trying to find out how far he can travel in 5 hours. So I'm going to put a 5 on the bottom instead of a 1, okay? So one thing I can quickly see when I'm looking at this problem is that if I take 2.5 and I double it, that I get 5. Okay, which means I'm taking it and I'm multiplying it by 2. You guys remember with the equivalent fractions, we can do that. Okay, so long as we do it to the numerator as well. So if I take 180 and multiply it by 2, I'm going to get 360. Okay, so 360 miles in 5 hours. Now, if I have this same problem, set it up the same way I just did, sometimes we don't easily see that we can multiply the denominator times something to get the second denominator. Okay, so if I don't see that, and I'm trying to find out what this top number is, I can use cross multiplication and division to solve it. So what that means is I'm going to take and multiply the two numbers that are across from each other. So 180 times 5. And then I'm going to, the other number, the one that's not included in that cross, I'm going to take and divide by that. Okay? So I'm going to grab a calculator, do 180 times 5. And then I'm going to divide 900 by 2.5. And I get my 360 again. So x equals 360. Okay, so all of these steps, all of these ways are perfectly okay when you're working with proportions. Now, sometimes one way is a little quicker than the other. Okay, so you can use any of these when you're trying to solve these problems. Okay, so now we're going to fill in the table. So in 2.5 hours, he has traveled 180 miles. That's given to us in the problem. In 5 hours, we just found he had traveled 360. Now, when we're looking at the table, you guys see how it's increasing by 2.5 each time, which means all I have to do is keep adding this 180 to the number before it to get my next number. So I've got 180, I've got 360, so I can take 360 and add another 180 to it. That gives me my 540. Okay, I'm going to add another 180, and I'm going to get 720, and then one more 180 gives me my 900. Okay, now the only time we can do this, as you can see, is when we are increasing by the same amount in between each one. Okay, if it's increasing by different numbers, say for instance it's going like 1, 2, and then it skips up to 5, you can't keep adding. You are going to have to use one of the methods that I showed you for number 1. Okay, so number 3, how many more miles does Mario travel in, or excuse me, I read that wrong. How many miles does he travel in 1 hour? Okay, well we found that in the first problem, so I'm just going to copy it back down. So we said 180 over 2.5, 1 hour, and we got, I don't remember what we got, I think we got 72. 180 divided by 2.5. Yeah, 72. So 72 miles in 1 hour. So if I wanted to explain my solution, I could say something like he traveled 180 in 2.5 miles, so you have to divide to find out how far he travels in just 1 mile. Or excuse me, 1 hour. Okay. Concept of proportionality, the value of the ratio of two proportional quantities. So the value of the ratio of two proportional quantities is what gives us our constant of proportionality. Okay, and we're going to talk a little more about what that means. Represented by the equation. Okay, so I'm going to write our equation. And you need to write this down, y equals kx, where k is our constant of proportionality. Okay, y represents the y values or the dependent values, and we'll talk more about what that means. And then x represents the x values in the table or graph. Okay, so here's our table. It is asking us to examine the patterns by taking y, you guys see this over here, and dividing by x. So what that means is I'm going to take my value for y, so for my first one I've got 12, and I'm going to divide by x, which is 1. So for this one I get 12. The second one, 24 divided by 2, still 12. 36 divided by 3, I've got 12. 48 divided by 4, 60 divided by 5. Okay, so we get 12 each time. Okay, so we know that these values for x are all of our x values in the equation. The ones for y are our y values. This number that we get over here, this is what we call our constant of proportionality. If it is the same every time you divide y divided by x, okay, then you have your constant of proportionality. Now, if you get something different, it does not have a constant of proportionality, and it's not a proportional relationship. Okay, so how do you know that the number of feet is proportional to the number of inches? I just talked to you about it. I know it because I got the same answer every time I divided y by x. Okay, the second question says, using x, the number of feet, how do you find y? What do we do to find the number of inches if we know the number of feet? Well, remember I told you earlier that we have, this was right, okay. So we're not writing the equation yet, but we are going to write an equation for this, okay? So how do we find it? We would multiply multiply value of y by 12. Wait, hold on, there's the wrong number. Value of x multiply the value of x times, 12. Okay, so we know that y equals inches in our problem. K is equal to 12 from our problem. X is equal to the number of feet. Okay, and now we're going to write our equation. Remember, I told you y equals kx. So for this problem, y will equal, and we'll just plug in the value for k. We do nothing to the y and the x, so 12x. Alright, so here's our next example. While training for a marathon, Keith's watch reported how many calories he burned at each mile marker. The data is shown below. The number of calories is the number of calories proportional to the number of miles, so we have to find that out. What we just did was y divided by x, but these aren't tabled. One thing you should always be aware of when you're looking at a table, the first thing you see is always going to be your x value. The second line should always be your y. So if I'm taking this and doing y divided by x, I'm just going to divide bottom by top. So 117 divided by 1 is 117. 234 divided by 2 is 117. 351 divided by 3, 117. You guys see how I'm checking each and every one. I'm not just assuming. Divided by 4 is 117. 585 divided by 5 is 117. So the answer to this would be yes. Okay, my explanation would be that every time I divided calories burned by how many miles he ran, that I got the same number. I have a constant of proportionality. Okay, so the next day he ran 7.5 miles. How many calories did he burn? Well, we already know that this is our 117 is our constant proportionality. So if I set this up with an equation, remember k times x, so 117x, miles, looking up here, is our x value. So I could plug that in. So I'm trying to find y. 117 times 7.5. And that gives us, I put that in wrong time, 7.5 times 117. 877.5 calories. Okay, what is the constant proportionality? 117. Write an equation to explain the relationship. I wrote the equation already, which was y equals 117x. Okay? Alright, here's our next one. Y divided by x. Okay, so 6 divided by 1.5. 16 divided by 4. I don't know what I did on that one. I know it's 4. 22 divided by 5.5. 30 divided by 7. Okay, so this one is proportional because we got the same number each time and k equals 4. Okay, we're going to do it again. 3 divided by 2, 1.5, 6 divided by, 6 divided by 4, 1.5, 9 divided by 6, 1.5,